Hi there. During this session I'm going to be talking about projectile motion, and that's motion through the air when we need to consider both an x and y component to the velocity. So let us consider how we need to approach these problems. First thing we need to do is we need to separate the x and y components of motion. Now if we look at the horizontal component, this is going to be unaffected as there's no forces acting on it. So that means the horizontal component is always going to be constant, whilst the vertical component will be impacted by the acceleration downwards due to the force of gravity. And again, this is a constant acceleration, therefore we can make predictions about it using our equations of motion. So how do we approach these problems? Well, there's a couple of problems. Now this type of problem is known as a horizontal launch problem. Okay, and what we see here is the launch is horizontal, and we see that in this case the x component is constant, 100 meters per second, but the y component of velocity increases as the object falls. So that's a typical type of question. Let's look at this in a little more detail. So for problem solving, it's generally always useful to recognize from the starting point that we're going to have a positive x direction is going forward and a positive y direction is going up from the point of launch. Okay. Now once we've agreed to that, so we've got our x and y components, and we've got our time is t equals 0. Now we use the y component of velocity, which is initially 0, to calculate the time to reach the ground. So thinking back to a falling object, we recognise that the displacement, or the distance it takes to reach the ground, is equal to half a t squared. From there, if we, depending on what numbers we know, we should know the acceleration, and we might know the time, the distance to the ground, therefore we can work out the time, and then we can then work out the displacement, because the displacement is going to be the time multiplied by the x velocity, or velocity of the x component. So that's how to handle horizontal launch problems. We've also got to consider situations when the object is launched at an angle. Okay. Just like this. Now here, again, it's really useful to consider the having the x and y components set up in exactly the same way as we have done before. So let's consider the time of flight. Okay. We have an object which has been launched at an angle theta with a set velocity. Now we know that we have velocity vertical component and velocity horizontal component. Those are two components. Now if we think about this journey, its maximum height is going to be at the point when the vertical velocity is going to be 0. Okay. We know that the acceleration for the vertical component is always going to be minus g. And this means that if we know the time it takes to go up and down, that means by looking at the we can use that value to work out the time it takes to impact. Okay, so this would be 2 times the vertical velocity divided by g. Okay. So we find the vertical component. Vertical v is v sine theta. We use the formula v equals u plus at. We know at the maximum height v equals 0, a is minus g, and we also know that u is the vertical velocity, which is v sine theta. So as we know that, we can work out what the maximum, the time it takes to get to the maximum height, which is v sine theta divided by g. And if we multiply this 2, it gives us the time of impact, because remember it takes the same amount of time to get up as it does to get back down again. So that's how we think about these questions. Let's see if you can do a question now. A ball is kicked at an angle 40 degrees with a velocity of 10 meters per second. taking g equals 10 meters per second squared, we're just using that simplified value here just for these calculations, how far does it travel horizontally? So think about how you're trying to answer this question. Pause, answer the question, and let me take you through how I'd recommend you do it. Think about this visually. First of all, so we've got 40 degrees and a velocity of 10 meters per second. That's our starting point. Now, we want to know what the distance is. We know what, if we're looking at the different components, we know what our initial velocity is, and we know what the acceleration is. And we don't know what our time is. So there's lots of unknowns in this situation. So we only have two values when we need three values. And these are the things which are kind of given to us straight away. Now if we think about the problem, what we can do, we're ignoring air resistance, so the final vertical component of the velocity will be equal and opposite to the initial component. So that means that the final vertical component is going to be minus 10 sine 40 degrees meters per second. Remember, what goes up must come down. Now, if we use an equation of motion with uniform acceleration, we've got more values which are available to us. So what we can do is v equals u plus at, rearranging to make this object t, v minus u divided by a, substituting the values we know, and therefore the time equals 1.286 seconds. Now if we return to the horizontal component now, recognising speed equals distance divided by time, and rearranging that distance equals speed times time, we know that the horizontal component has a velocity of 10 times cos 40 degrees, and we know the time it has is 1.286 seconds. So that gives me a final distance of 9.9 meters, rounding up. Hopefully that will give you an insight in how to handle these type of questions. Just be ready for, and I'm going to give you some advice here, what's known as the classic monkey and the hunter questions. What we'll find here is you have to consider two situations. You have to consider the motion of a bullet and the motion of a monkey, which often simultaneously lets go of the branch at the same time as it hears the shot of the gun. One of the key things here is we've got to remember that both the bullet and the monkey will fall at a rate of 9.81 meters per second squared. I think the secret is the monkey normally dies in these questions. But your question is, how can you prove that? So often what you have to do is prove that the location of the bullet after a certain amount of time is going to be exactly the same as the location of the monkey. But these are some questions which I'm quite sure you're going to be provided for in the future. So with that, that's a breakdown of how to handle projectile motion.